and let me share the screen. കുറേ മൾട്ടിപ്പിൾ അല്ല കുറേ ന്യൂമറിക്കൽസ് ഞാൻ ഡിസ്കസ് ചെയ്തിട്ടുണ്ട് ഓൾറെഡി. നെക്സ്റ്റ് in the previous class we studied friction, right? അല്ലേ ലെമിയ, ദിയ, തൃഷ, we studied friction.
Yes.
And I discussed one numerical problem from solved example. So we have studied two types of friction: static friction, kinetic friction. We have studied everything. So next, please give a heading: banging of a rod. Okay, can you see the screen? Banging of a rod. There is a big derivation. That derivation is important. So after this derivation I will discuss one question based on the formula. So what do you mean by banging of a rod? സ്കൂളിൽ എടുത്തതാണല്ലോ അല്ലേ? ദിക്ക് അറിയാമോ എന്താണ് ബാങ്കിങ് ഓഫ് ദ റോഡ് എന്ന് പറഞ്ഞാൽ? എന്താണ്, വാട്ട് ഈസ് ദ ബാങ്കിങ് ഓഫ് ദ റോഡ്, ഓർ വാട്ട് ഈസ് ദ പർപ്പസ് ഓഫ് ബാങ്കിങ് ഓഫ് ദ റോഡ്? ഫ്രിക്ഷൻ ഇൻക്രീസ് ചെയ്യാനോ? Trisha, what do you mean by banging of the road? Trisha?
When the road is tilted to a certain angle in order to increase friction at the point.
Yes. So if there is a sharp turning, okay, you might have noticed, if there is a sharp turning, you can see that outer boundary of the road, it is above from the ground, compared to this boundary. Clear? Compared to this boundary, the upper boundary, clear? This boundary is appear to be a little bit higher compared to this boundary. Or I can say that at the turning the road is kept at some small angle theta with the ground. This is said to be banging of the road. Clear? Understood? Okay. This prevents from the car to slip away from the road. Clear? If the banking of the road is not available, what happens? There is a good chance that the car may slip away from the road. ഇങ്ങോട്ട് സ്ലിപ്പ് ചെയ്ത് പോകാനുള്ള ചാൻസ് ഉണ്ട് അല്ലേ? If the road is horizontal, if there is a horizontal turning and car is moving, turning along this turn, what happens? There is a tendency that the car has a tendency to slip and move away from this track. So to prevent the slipping, okay, what happens? We keep the road at a certain angle. അല്ലേ? ഈ റോഡ് ചെറുതായിട്ടൊന്ന് ലിഫ്റ്റ് ചെയ്യാണ്. Outer boundary of the road a little bit higher, okay, compared to the inner boundary, so that the car will not slip away from the track. Clear? Understood? Diya, Trisha, Lemia, okay.
Yes, sir.
Okay, also the banking of the road എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഇതാണ്, clear, keeping a small angle. Okay, the road will be kept at a small angle with the horizontal. Also there will be some frictional force. Clear? The road will not be so smooth, there will be definitely some friction on the road. So this friction and this angle together prevent the car from skidding away from the track. Okay, this angle along with the friction prevent the car from skidding away from the track. Okay, I hope you have understood. So I'm going to find out the safest maximum speed of the car, so that the car will not slip away from the track. Okay, that is my objective. My objective is maximum allowable speed of the car. That is my objective. Okay, അപ്പോൾ ക്ലിയർ ആയല്ലോ? അപ്പോൾ ആംഗിൾ ഈസ് ദർ ആൻഡ് ഫ്രിക്ഷൻ ഈസ് ഓൾസോ പ്രസൻറ്റ്. ഓക്കെ, സോ നൗ look here. So suppose a car, okay, is turning. Okay, there is a turning, and at the turning there is a small angle is there, and ഇങ്ങനെ ഒരു ടേണിംഗ് ആണ് കേട്ടോ. ഓക്കെ, കാർ ഇങ്ങനെ ഒരു ടേണിംഗ് ക്രോസ് ചെയ്യാണ്, circular turning. Okay, we assume that it is a perfectly circular turning. All of you, can you follow? Clear? The car is taking a turn like this. This is the shape of the road. In the turning, the road look like this. The car has to turn like this. It is almost a circular turning. Till this step, are you okay? Clear? Circular turning. Okay. Okay, circular turning ആണ്. Okay, ഞാൻ കുറച്ച് നേരത്തേക്ക് മായ്ക്കട്ടെ. Okay. So listen, if the car is on the road, there will be normal reaction. ലെമിയ ശ്രദ്ധിക്കുന്നുണ്ടല്ലോ അല്ലേ? ലെമിയ, ദിയ, there will be definitely normal reaction. Clear? This road apply a normal force on the car. Definitely there will be normal reaction. Normal reaction is denoted by capital letter N. ശരിയല്ലേ? Okay ആണോ? All of it clear?
Yes.
And
Yes.
this car has mass m. Suppose this car has mass m, so its weight will be vertically downward. Earth attract the car vertically downward. The weight of the car, let it be mg, where m is the mass of the car. I am writing all possible forces acting on the car. What are the different types of forces acting on the car? One will be the normal reaction that is applied by the inclined road. Clear? This road apply a normal reaction on the car. Mg is the force of attraction of the car by the earth. Earth attract ചെയ്യാണ്. Earth കാറിനെ attract ചെയ്യാണ് with the force mg. Any other force acting on this car? Any other force? So the car is taking a turn like this. As the car taking a circular turn like this, what happens is the car has a tendency to slowly move upward. Clear? Because if the car is moving at very high speed, this car has a small tendency to go upward. Skid ചെയ്ത് പോകാനുള്ള ഒരു ടെൻഡൻസി ഇല്ലേ അല്ലേ? ശരിയാണോ? കറക്റ്റ് അല്ലേ? എന്താ മിണ്ടാത്തെ അല്ലേ? ശരിയല്ലേ? ഞാൻ ഒന്നുകൂടി പറഞ്ഞുതരാം. The car is moving in a straight path and taking a huge turn at very high speed. Taking a circular turn at very high speed. അങ്ങനെയാണെന്നുണ്ടെങ്കിൽ the car has a tendency to slowly പതുക്കെ ഇങ്ങോട്ട് ഡ്രിഫ്റ്റ് ചെയ്ത് പോകാനുള്ള ഒരു ടെൻഡൻസി ഇല്ലേ? If the friction is not sufficient, if the friction between the tire and the road is not sufficient, the car will definitely skid away from the path. ഇങ്ങനെ സ്കിഡ് ചെയ്ത് പോവും. ശരിയല്ലേ? സ്ലിപ്പ് ചെയ്ത് പോവും. You agree with me? Clear? Trisha, Diya?
Yes, sir.
Okay, Trisha, have you understood? Okay.
Yes.
So if the friction is not sufficient, definitely it go little bit. Okay, it has a tendency to skid like this. So that is prevented by the friction. Clear? The static friction will prevent it from moving upward. The static friction will be downward. Because of the static friction, Fs ഉണ്ടാവും. Because of the static friction, it prevent the car from moving away from this track. Okay, Fs ഉണ്ടാവും. Till this step, are you okay? Fs is okay. Clear? Static friction. Trisha, Diya, മനസ്സിലായോ? Fs എവിടെ? Okay. Actually it is this part is very difficult to understand. I am writing all possible forces acting on the car. One is normal reaction, other one is weight of the car. Yes, definitely frictional force will be there. Clear? If the friction is not available, this car has a tendency to skid away from the track. Clear? Fs will be downward. Any other force?
സൈഡിലേക്കാണോ ഡ്രിഫ്റ്റ് ആവണേ അതോ താഴേക്കാണോ?
താഴേക്കല്ല, മുകളിലോട്ട് ഡ്രിഫ്റ്റ് ആവുള്ളൂ. ശരിയല്ലേ? ഒന്ന് ആലോചിച്ചൊക്കെ, പെട്ടെന്നൊരു ടേണിങ് ചെയ്ത് കഴിഞ്ഞാൽ എന്താ, കാർ അങ്ങോട്ടല്ലേ ഡ്രിഫ്റ്റ് ആയി പോവാ? ശരിയല്ലേ? അല്ലേ? അതങ്ങനെയാ. നല്ല ഹൈ സ്പീഡിൽ പോയി കഴിഞ്ഞാൽ കാർ ഈ ട്രാക്കിൽ നിന്ന് ലെഫ്റ്റായി പോവും അല്ലേ? ട്രാക്കിൽ നിന്ന് അങ്ങനെ അങ്ങോട്ട് ലെഫ്റ്റായി പോവും. കാർ പോണത് ഇങ്ങനെയാണ്, ഒരു വളവ് തിരിയാണ്. ഇത് ഇങ്ങനെ, മനസ്സിലായില്ലേ? ഗ്രൗണ്ടിന് പാരലായിട്ടാണ് കേട്ടോ. ഫോളോ ചെയ്യാൻ പറ്റുന്നുണ്ടല്ലോ? ഗ്രൗണ്ടിന് പാരലായിട്ട് ഒരു ടേൺ ചെയ്യാണ്. ഇങ്ങനെ ഒരു ടേണിങ് ഇടുമ്പോൾ ഇത് കാറിന് അങ്ങോട്ട് ഡ്രിഫ്റ്റ് ചെയ്ത് പോകാറുള്ള ടെൻഡൻസി ഉണ്ട്. പക്ഷേ സ്റ്റാറ്റിക് ഫ്രിക്ഷൻ പ്രിവെൻറ്റ് ഇറ്റ്. ഓക്കെ, ക്ലിയർ? Trisha, are you okay? Trisha? Okay. If you don't understand, please tell me, I will repeat. So this part is very difficult to understand. So Fs is there. Okay, that part is also clear. Any other force? Any other force acting on this body? Okay, there is one more force, that is centripetal force, but that part I will discuss later, not right now. Listen, let me draw a vertical dot lines like this. Let me draw a vertical dot line like this. This angle is theta. Can you tell me what about this angle? Can you tell me that angle? മനസ്സിലാവുന്നുണ്ടോ? Let me draw a vertical dot line like this. The normal reaction and this vertical dot line. What will be the angle between them? Can you guess? Can you guess that angle? No response.
Cos theta. Sir, can it be theta?
This angle, I am saying that this angle is theta. Can you tell me the reason? Can you tell me the reason why that angle is theta? Please tell me. Why that angle is theta? If you have no idea, I will explain that. This normal reaction is extended like this. Clear? This dot line extended like this. This picture is clear to you? Understood? This picture is clear to you?
Yes.
Trisha, this picture is clear?
Yes.
Okay, that dot line is extended downwards and that becomes mg. It's clear from the picture. And normal reaction is this one, 90 degree, making 90 degree with the plane. That normal reaction is drawn. It is also extended. Okay, it is also extended. 1 minute. My picture is not so perfect. Let me redraw the picture again. ചെറുതായിട്ടൊന്ന് റീഡ്രോ ചെയ്ത് നോക്കട്ടെ. ഓക്കെ, ഇവിടെ നിന്ന് ഞാൻ വരച്ചേക്കട്ടെ. ജസ്റ്റ് 1 minute. This is the normal reaction. Listen carefully. This is extended like this, normal reaction, and this is the I have drawn a perpendicular dot line like this. Perpendicular dot line like this. It is extended downward. It becomes mg. This part is clear to you? All of you clear this part? Understood?
Yes, sir.
Trisha, clear? Trisha? This picture is clear. What I am saying is this angle is theta. Okay, I will tell the reason also. Okay, I will tell the reason also. Look at this picture. After explaining this angle theta, I will delete the unnecessary terms. This angle is 90 degree. You agree with me? Clear? This angle is 90 degree. You agree with me, Trisha? Please tell me. This angle is 90.
Yes.
Are you okay? Then what about this angle? After that I will delete this unnecessary angle. Okay, my objective is I want to make you understand that this angle is theta.
Minus theta.
Yes, this angle will be 90 minus theta. Trisha, Diya, all of you clear? You agree with me?
Yes, sir. Yes, sir.
Then what about the smaller angle? Can you see a smaller angle over here? Clear? ഇവിടെ ഒരു ആംഗിൾ കാണുന്നില്ലേ? ശരിയല്ലേ? Can you see that angle? Why no response?
Yeah.
You see that this angle 90 degree. You agree with me? This angle is 90 degree. Is that okay? No response from this your side. Is it 90 degree?
Yes, sir.
Clear? That is 90 degree. ഫോളോ ചെയ്യാൻ പറ്റുന്നുണ്ടല്ലോ? ഞാൻ ഒന്നുകൂടി ഹൈലൈറ്റ് ചെയ്യണോ? ഓക്കെ, ഐ ഹോപ്പ് യു ഹാവ് അണ്ടർസ്റ്റുഡ്. I will highlight again using different color. You see that this angle is 90 degree. This highlighted total angle is 90. This highlighted angle is 90 degree. So in this ഇവിടെ ഫുള്ളും 90 degree ആണ്. Since this part is 90 minus theta, this angle must be theta, so that if you add them you will get 90 degree. Correct? 90 minus theta plus theta will be total 90 degree. Understood? All of you clear? Trisha?
മനസ്സിലായി.
ദിയയ്ക്ക് മനസ്സിലായി. Trisha, are you clear? This angle theta, you got the idea?
Yes, sir.
Okay. You can take screenshot because I will delete this unnecessary angle later. Okay, if I show all the angles you will be confused with the picture. That's why I will delete this. Okay, so this angle is theta. Then can I say that this angle is theta? You agree with me? Correct? You see, these two are opposite angles. Can you understand that? These two angles are opposite angle. Since it is theta, the opposite angle will also be theta. Correct? Understood? No response. Correct? Trisha, no response from your side. You agree with me? Okay. You can take some screenshot. So I want to delete this 90 minus theta, okay, unnecessary part I want to delete, otherwise the picture will be highly complicated. I want to delete. So ultimately you understood that this angle theta. Okay, clear? Trisha, Diya? Okay.
Yes, sir.
If you okay, later if you want the reason, okay, you do one thing, you take the screenshot or take the photo on your mobile phone, so that I can delete it. I want to delete 90 minus theta, this theta. Okay, unnecessary part I don't want to keep. So okay, clear? I hope you understood. Okay, all of you clear? Can I delete this part? Okay, Trisha, okay le? Trisha, okay? Diya, okay analo?
Okay.
Okay, let me delete this unnecessary parts. Okay, otherwise the picture will be highly complicated. That's why this one also I want to delete. Okay, now listen carefully, examine this normal reaction rotated through an angle theta. Is that correct? This normal reaction rotated through an angle theta. So I can say that this normal reaction has a component n cos theta this side. You agree with me? Clear? This normal reaction turn an angle theta. Correct? Turn an angle theta. If a vector turn an angle theta, its component along the new axis, the component along the new axis will be n into cos theta. Clear? You agree with me? Correct? Trisha, Diya?
Yes, sir.
Diya, you understood. N has component, n is rotated through an angle theta. So in the new axis, after rotating theta, n has a component n cos theta. Trisha, you agree with me? Trisha? Please reply.
Yes, sir.
Okay, okay. So n cos theta is one component. Now let me take the vertical component of n cos theta. N cos theta, the vertical component of n cos theta will be, of course, n sin theta. You have already studied that. In the chapter projectile motion, you have already studied components. N cos theta has a vertical component, 90 degree taken. Clear? 90 degree taken. N cos theta has component n sin theta. So the vector n has n cos theta in the direction of theta, and vertically it has the component n sin theta. So n is resolved into two components. One is n cos theta, other one is n sin theta. You agree with me? Clear? All of you clear?
Yes, sir.
Okay.
Yes, sir.
Diya, എന്തെങ്കിലും ഡൗട്ട് ഒക്കെ ഉണ്ടെങ്കിൽ ചോദിക്കാം കേട്ടോ. Okay, so this part is clear. Let me delete it. So okay, any other thing is there? Okay, Fs. Now I am resolving Fs also. Fs is going downward, not downward, along this road, അല്ലേ? Parallel to the road. റോഡിന് പാരലൽ ആയിട്ടാണ് ആര് വരുന്നത്? പാരലൽ ആയിട്ടാണ് the Fs. Fs is there. Now Fs has two components. What are the two components? What about this angle? Can you tell me? If you carefully examine this picture, this angle is theta. You agree with me? Clear? Trisha, Dia, can you see the screen? Can you see the screen? Hello?
Yes, sir.
Okay. Can you see the screen, Dia?
No, sir.
No. 1 minute.
Yes, sir. Yes, sir.
ഒരു മിനിറ്റ് ഇപ്പോൾ വരാം ഒരു മിനിറ്റ്. Okay, all of you clear? This theta, are you okay? Trisha, Dia, please reply. This angle theta, you agree with
Yes,
me?
sir.
Yes. Because they are alternate angles. You have studied in the lower classes, 9th standard. This theta, this will also be theta, alternate angle. Now, Fs is rotated through an angle theta. Understood? Fs is rotated through an angle theta. So, Fs has a component. Fs has a component Fs cos theta towards left. You agree with me? Clear? No response. Correct?
Sir. Yes, sir.
Trisha, okay. Fs is, imagine like this. Fs is rotated through an angle theta. So in this new axis or in this new direction, Fs has component Fs cos theta. And Fs has the vertical component which will be downward. Okay, it will be downward. One component is horizontal, Fs cos theta. Other component will be vertically downward, which is Fs sin theta. Fs has two components. One is horizontal component, which is Fs cos theta, and the other one is vertical component, Fs sin theta, vertically downward. Till this step, are you okay? All of you clear?
Yes, sir.
Okay. Now, one more thing I would like to explain. Okay. As the car taking a sharp turn here at this point, the car is about to take a sharp turn. Clear? Sharp turn. So, sharp turn എന്ന് പറയുമ്പോൾ എങ്ങനെയാണെന്ന് വെച്ച് കഴിഞ്ഞാൽ ഇവിടെ നോക്ക്, ഷാർപ്പ് ടേൺ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ, ലുക്ക് ഹിയർ, ഐ വിൽ എക്സ്പ്ലെയിൻ ദാറ്റ്. ദ കാർ ഈസ് ടേക്കിംഗ് എ ഷാർപ്പ് ടേൺ ലൈക്ക് ദിസ്. ഇങ്ങനെ ഒരു ഷാർപ്പ് സർക്കുലാർ ഷേപ്പിലാണ്. ദ കാർ ഈസ് ടേക്കിംഗ് എ ഷാർപ്പ് ടേൺ ഹൊറിസോണ്ടലി ആണ് കേട്ടോ. ദ കാർ മൂവിങ് ഹൊറിസോണ്ടലി, ടേക്കിംഗ് എ ഷാർപ്പ് ടേൺ ഇൻ എ സർക്കുലാർ പാത്ത്. സർക്കുലാർ പാത്തിൽ ഒരു ഷാർപ്പ് ടേണിങ് ഉണ്ടെങ്കിൽ this has a center also. This circle has a center. Correct? You agree with me? This circle has a center here. You agree with me? Correct?
Yes.
Okay. So of course this car has a tendency to go like this. This car has a tendency to go like this. It is said to be centrifugal force. Centrifugal force എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ a body moving in a circular track. A body moving along a circular track has a tendency to move like this, apply a force like this. ഇങ്ങനെ ട്രാക്കിൽ നിന്ന് എസ്കേപ്പ് ചെയ്ത് പോകാനുള്ളൊരു ഫോഴ്സ് ഉണ്ട്. ദാറ്റ് ഈസ് സെഡ് ടു ബി സെൻട്രിഫ്യൂഗൽ ഫോഴ്സ്, mv²/r. Have you studied centrifugal force? I will explain.
So what's the difference between centripetal force and centrifugal?
Okay. Then I will explain another way. Centripetal force, let me explain that. Okay, centrifugal force and centripetal force both are having different directions. Listen, I will explain that. Don't worry. Look here, a body, I have taken a rope. Okay, I have taken a rope. I am holding this point, this rope, this point I am holding with my hand, and this point there is a body having certain mass. I am rotating this body like this. Okay, I am rotating this body like this, moving in a circular track. So every time I am applying a force in this direction along the rope. You agree with me? Clear? You agree with me?
Yes, sir.
That force is centripetal force. That force is mv square by r. Have you studied that formula? Mv square by r.
Yes.
So I repeat, a body moving along a circular track, every time I am holding this rope at this point, every time I must apply a force towards the center. Towards the center, I am applying certain force on this body to keep in the same circular track. That force is mv square by r. If such force is not there, this body will not be able to move along a circle. So every time a force is required towards the center, so that the body will be revolving along a circle. That force is said to be mv square by r. It is towards the center. Is that okay? Clear? Trisha, Diya?
Yes. Yes, sir.
Okay. I explained this concept in the another manner so that you got confusion. So some kind of force towards the center to be applied, so that the car must be moving in a correct circular track. Clear? During the turning, the car is moving along a circular track. So some kind of force mv square by r to be applied on the car. Clear? Towards the center. By some way or other, mv square by r is necessary, which is to be applied on the car. Otherwise, the car will be escaped from the circular track. Clear? You agree with me? Understood?
Yes.
Trisha, okay. Okay. So I think the picture, I hope you have understood. Okay, there are lot of component forces, but I cannot skip anything. Okay, so I explain every terms. So derivation is there, but it is not necessary to write all the steps. Okay, the important steps only to be written in the exam. Okay, this picture is required. This picture is necessary. Okay, so I have written all the possible force acting on the car. Clear? What are the forces? Different forces. One is normal reaction. I have resolved the normal reaction into two components. One is n cos theta upward and n sin theta towards left. And there is a frictional force along this line. I mean along this road. There is a static friction Fs. Fs has resolved into two components. One is Fs cos theta left side, other one is Fs sin theta downward. Now only one force is pending, which is centripetal force. The car is taking a circular turn, means that the car is moving along a circle. Since the car is moving along a circle, some kind of force towards the center to be applied. Okay, that force mv square by r is necessary. This mv square, if the mv square by r is not present, the car cannot move along a circular track. So mv square by r must be available there. Okay, all of you clear? Okay, understood? Okay.
Okay.
Now I am equating net horizontal force. Tell me, what is a net horizontal force? I have resolved into horizontal and vertical motions. Net horizontal force, please tell me what is that? Net horizontal force net horizontal alla, net vertical force, please tell me. Net upward force, net vertical, sorry. Net upward force, let me write like this, is equal to net downward force. You agree with me? You agree with me?
Yes, sir.
Why net upward force equal to net downward force? The car is not vibrating up and down. You agree with me? Car remains on the road, correct? Car remains on the road. Car is neither going upward or downward. Car is in vertically equilibrium state. Vertical motion illa, up illa, down illa. Up and downward motion is not there for this car. So net upward force will be exactly equal to net downward force, so that the car does not have any vertical motion. Car remains on the track, no vertical motion. സോ നെറ്റ് അപ്വേർഡ് ഫോഴ്സ് എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ യു ക്യാൻ സി വൺ അപ്വേർഡ് ഫോഴ്സ് ഈസ് എൻ കോസ് തീറ്റ. ശരിയല്ലേ? ഓക്കെ ആണോ? 1 മിനിറ്റ്, ഞാൻ ലെമിയയ്ക്കൊന്ന് മെസ്സേജ് ചെയ്തേക്കട്ടെ കേട്ടോ ദിയ. ഓക്കെ, ലെമിയ ക്ലാസ്സിലില്ല, ഞാൻ ജസ്റ്റ് ഒരു മെസ്സേജ് ഒന്ന് കൊടുത്തേക്കട്ടെ. I'm taking the class on the exam point of view, so a few steps I don't want to write. A few steps I don't want to write. Okay, now but I will make you understand the concept. Okay, simplification part I want to skip. I am teaching you on exam point of view. What is the upward force? Can you tell me? Net upward force is n cos theta. You agree with me? Clear?
Yes, sir.
Net upward force. I resolve all forces vertically and horizontally. Net upward force is n cos theta. And what is net downward force? Net downward force, from this picture, mg is vertically downward. Fs sin theta is also vertically downward. Correct? So mg is vertically downward plus Fs sin theta is also vertically downward. You agree with me? Clear? Understood?
Yes, sir. Yes, sir.
Okay. And one more thing. In the previous class, you have studied that static friction Fs. Static friction or the maximum static friction. I am taking the maximum static friction. The car is about to drift upward. Okay. The car is moving with a very high speed. Okay, maximum speed. The car is moving with the maximum speed. The car is about to drift upward. Okay, slowly start drifting upward. So Fs max, static friction, maximum static friction, equal to mu s into n. Have you studied this formula in the last class? Do you remember this formula? Static friction is equal to mu s into n. Trisha, do you remember that formula? Trisha?
Yes, sir.
Okay. So I will write it later. Fs equal to mu s n. I will definitely write later. Let me write the another equation. Then horizontal force. I am checking horizontal force. This mv square by r to be provided by someone else. Understood? You agree with me? This force mv square by r must be provided by some forces, because mv square by r is necessary for the circular motion. You agree with me? Clear?
Yes, sir.
So anybody moving along a circle experience a force mv square by r. This force must be provided by any kind of force, friction or part of normal reaction, whatever it is. I definitely need mv square by r. So which forces provides mv square by r? What are the total forces towards left? Watch this picture. What is the total force towards left hand side? You can see that Fs cos theta is towards left. You agree with me? Clear? Correct? No response.
Sir.
Fs cos theta is towards left. You agree with me? Okay. Fs cos theta is towards left. Any other force towards left? Carefully watch this picture.
Sin theta.
N sin theta is also towards left. You have to draw this picture. This question will be asked in the exam. But the all simplification steps you need not show in the answer paper. Okay. So Fs cos theta plus n sin theta is the total force towards left. This total left side force must be equal to centripetal force. Centripetal force is necessary, otherwise car will not be able to move along circle. Here you can see that the car is moving along a circle. So mv square by r is necessary. So some part of the forces must be there which provide mv square by r. A part of fs provide mv square by r. Also a part of n also provide mv square by r. So fs cos theta plus n sin theta, these two forces together provide the centripetal force. As a result, the car is able to rotate or move along a circle. You agree with me? Clear?
Yes, sir.
ദിയയ്ക്ക് മനസ്സിലായെന്ന് വിചാരിക്കുന്നു. ദിയ അല്ലേ? ഓക്കെ ആണല്ലോ, ശരിയല്ലേ? ആ, ഞാൻ എക്സാം പോയിന്റ് ഓഫ് വ്യൂയിലാണ് ക്ലാസ് എടുക്കുന്നത്. So in exam, this picture you have to draw this set of two equations and one substitution you can write. After that you simply write on simplification maximum speed equal to this. Okay, all simplification step is not necessary. You will get the mark. So you see fs equal to mu s n, correct? Understood? Clear? Diya, Trisha, fs equal to mu s n. So in this set of equation, here you can see fs, here also you can see fs. Fs is mu s n, alle? So let me write equation 1 and 2 again. Equation 1 onnu koodi ezhudhan povana. N cos theta is equal to mg plus fs sin theta. Fs is nothing but mu s n. You have studied that. Mu s n sin theta, equation number 1. And second equation will be again there is fs, mu s n cos theta plus n sin theta equal to mv square by r. Okay, all of it clear? Understood?
Yes, sir.
Okay, now some 2 or 3 steps I am skipping. Okay, I am not writing some 2 or 3 steps. I will give you the idea only, because I told you that I am teaching you exam point of view. So if you skip some 2 or 3 steps, definitely you will get mark. From the first equation, if you rearrange, you will definitely get the value of n. Understood? Clear? If you do the rearrangement, if you take the rearrangement, but I am not planning to write that. If you take the rearrangement, you will get an equation for n, correct? You have to substitute the value of n in the second equation. Okay, so in the exam you please add these two sentences instead of writing all steps. I will show you. New slide. Okay, in the exam, after writing all these 2 steps, you can write from 1. Okay, from 1 we get the value of n. Yes, definitely. From first equation, if you make some rearrangement, you will definitely get n. And substitute the value of n in the second equation, we get v. V is the maximum speed. So we get the value of n, substituting 2 and simplify. You just add this sentence only. Simplify. We get v equal to one important formula you will get, root of. Definitely we get a v square. We get the formula for v square. Taking square root, v equal to root of rg into mu plus tan theta, mu s plus tan theta divided by 1 minus mu s tan theta. Some 2 or 3 steps we have skipped, but definitely don't worry, you will get the mark. You simply write these 2 sentences. That is enough. Okay, method is clear to you? Method is clear?
Yes, sir. Yes, sir.
Okay, so r. Okay, r is what I forgot to tell. R I have already explained that mv square by r ile r nu parnayal radius of the circle. Understood? Radius of the circle. The car is moving along a circle in the turn, right? that circle will have a radius, right? Radius, that is r. Okay, so v is the maximum speed. My objective is maximum safe speed so that the car does not skid away from the track. Okay, so the maximum speed, this formula is the maximum allowable velocity, okay, is equal to root of rg. Velocity cannot exceed beyond this value. If the velocity exceed this value, it is not safe. The car will be skidding away from the track. Okay, so the maximum velocity of the car must be limited to root of rg into mu s plus tan theta by 1 minus mu s tan theta. Okay, all of it clear?
Yes, sir.
Yes, sir.
Okay, there are two cases in EXA. The two cases also you have to add. Two cases. There are two important cases. One is banking is there. Banking is there, but no friction. There are two cases. The first case is banking is there. അതായത് upper boundary of the road is little bit higher compared to inner boundary. Okay, the angle is set. Okay, for this road the angle is set, but this road is extremely smooth. Clear? This road is extremely smooth, no friction at all. Clear? You agree with me? Banking is there but no friction. Okay, correct? All of it clear? So the theta is there. This is car. This is car aanu vicharikkata. Car aanu. Okay, taking a turn. Here mu s is equal to 0. Banking is there but no friction on the road. Road valla oil ulla road aanu. No, zero friction. Smooth road. In this formula, the maximum velocity must lower. The maximum velocity you have to substitute mu s equal to 0 in this formula. In this formula, if no friction at all, theta is there, but mu s you have to substitute mu s as 0. Mu s in 0 to edukka. Vs will be root of rg into this mu s becomes 0. This mu s also becomes 0. You will be getting only tan theta by 1. അല്ലേ ഈ mu s 0, ഈ mu s 0 ആയിപ്പോയി. Only tan theta by 1 is left. rg tan theta, you need not memorize this formula, only this formula to be memorized. From this formula you will get two cases. In exam, when you derive this formula, you have to add these two cases also. You need not memorize this formula. Okay, root of rg tan theta. Clear? Disha, Triya, understood?
Yes, sir.
Yes, sir.
Okay, two cases ile oranadana. Then second case എന്താണെന്ന് വെച്ചാൽ friction is there. Friction is there but no banking. Banking എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ lifting of the road. Understood? Banking means lifting of the road. So the road is horizontal road like this. ഇങ്ങനെ ഒരു ടേണിംഗ് ഉണ്ട്. The upper boundary is not lifted. Clear? It is a horizontal road ആണ് കേട്ടോ. This is a horizontal road. Clear? Banking എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ road is lifted. Upper boundary of the road is lifted by small angle. Here the theta equal to 0. Both the left boundary and right boundary of the road parallel to the ground, lying on the ground. Understood? There is no lifting of the road. You agree with me? Clear?
Yes, sir.
Clear? Theta equal to 0. A car is taking a turn. A car is taking a circular turn along this road. So here what I am saying is mu s is there. Mu s is there. Friction is there. റോഡിൽ ഫ്രിക്ഷൻ ഉണ്ട് പക്ഷേ ആംഗിൾ തീറ്റ 0 ആണ്. ഇൻ ദിസ് കേസ് ദ maximum safe speed will be, you have to substitute theta equal to 0 in this formula. Mu s is there, friction ഉണ്ട് റോഡിൽ, theta equal to 0, അതെ തീറ്റ ഈക്വൽ ടു 0, യു സീ ദാറ്റ് tan 0 വിൽ ബി 0. ചെയ്ത് കാണിക്കണില്ല കേട്ടോ. tan 0 വിൽ ബി 0, ഡിനോമിനേറ്റർ ഓൾസോ tan 0 വിൽ ബി 0, 1 mu s will be left. This tan 0 0, idum 0, so you will get root of mu s rg. order ഒന്ന് മാറ്റി എഴുതിക്കോട്ടെ. mu s rg എന്ന് എഴുതാൻ വേണമെങ്കിൽ mu s rg. mu s is the coefficient of static friction. Again, only this formula you need to memorize. These two are the two special cases. Okay, all of you clear? Understood?
Yes, sir.
Okay, so please write down. So this chapter is over. Okay, all the things, everything related to friction is now over. So this derivation you have to understand, and some 2 or 3 steps I have skipped, but that step, if you skip that step, definitely you will get full mark, don't worry. This picture is very very important. This picture you have to draw, and remember the 2 cases also. Okay, Disha, Triya, okay la?
Yes, sir.
Okay, please write down. Tell me if you have written that. Have you drawn this picture? Or if you want to draw the picture later, okay, no problem, I will send the PDF after the class. Okay, I will send the PDF immediately after the class. Okay, idonnu refer cheya. ഇനി ഒന്ന് ദിശ, ത്രിയ, please read this entire theory. If you don't understand any concept, please ask in the class itself. Okay, please read this entire theory.
Yes, sir.
Please read everything. If you have any doubt, please tell me right now.
Centrifugal forceും centripetal forceും ഒന്നുകൂടെ പറയുമോ?
സെൻട്രിഫ്യൂഗൽ ഞാൻ സ്കിപ്പ് ചെയ്യാണ്. സെൻട്രിഫ്യൂഗലും കൂടി ഇതിനകത്ത് പറഞ്ഞാൽ കൺഫ്യൂഷൻ ആവും. സെൻട്രിഫ്യൂഗൽ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ സെൻട്രിപീറ്റൽ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ അറിയാമല്ലോ, ദ ഫോഴ്സ് ദാറ്റ് ഐ മസ്റ്റ് അപ്ലൈ ഓൺ ദ ബോഡി, അല്ലേ? ശരിയല്ലേ? ഐ മസ്റ്റ് അപ്ലൈ ദിസ് ഫോഴ്സ് ടു എൻഷുവർ ദാറ്റ് ദ ബോഡി റിമെയിൻസ് ഇൻ ദ സർക്കുലർ ട്രാക്ക്, അല്ലേ? ഞാനിവിടെ ഒരു റോപ്പ് വെച്ചിട്ടുണ്ട്. എവറി ടൈം ഐ പുൾ ദ ബോഡി ടുവേർഡ്സ് എ സെൻറ്റർ, കറക്റ്റ് അല്ലേ? എവറി ടൈം ഐ മസ്റ്റ് പുൾ ദ ബോഡി ടുവേർഡ്സ് എ സെൻറ്റർ. So the centripetal force is the force that I am applying on the body to remains in the track, circular track. മനസ്സിലായോ? Trisha, centripetal force is clear to you? Centripetal?
Yes, sir.
Centrifugal I don't want to explain in this section, because if I explain both the kind of force you will be confused. Centrifugal എന്താണെന്ന് വെച്ച് കഴിഞ്ഞാൽ in the opposite direction the body has a tendency to move away from the track, അല്ലേ? This body exert a force in this direction, അല്ലേ? ശരിയല്ലേ? This body exert some force.
So basically centripetal forces when it's moving inwards, forces inwards, and centrifugal is when the force is outside.
Outwards, yes, correct. Clear?
സെൻട്രിപെറ്റൽ ഗ്രാവിറ്റേഷണൽ സെൻട്രിപെറ്റലും ഈ സ്റ്റോണിന്റെ കേസ് സെൻട്രിഫ്യൂഗലും ആണോ?
സെൻട്രിഫ്യൂഗൽ നമ്മൾ അങ്ങനെ യൂസ് ചെയ്യാറില്ല ആക്ച്വലി. ഓക്കെ, സെൻട്രിഫ്യൂഗൽ നമ്മൾ യൂസ് ചെയ്യാറില്ല. വി കോൺസെൻട്രേറ്റ് ഓൺലി ഓൺ സെൻട്രിപീറ്റൽ. ഓക്കെ, okay, I hope you understood. Okay, clear?
Yes, sir.
So please read everything. Shall I repeat anything? If you have any doubt, please tell me, I will clarify your doubt. Trisha, please tell me your doubt.
Yes.
Clear? All of you clear? This entire concept is okay?
Yes, sir.
Okay, then what is the time now? What is the time now?
9:23.
9:23 അല്ലേ? Okay, let me discuss one question. That will be the end of this chapter. So this chapter is over. Okay, ഇത് വേണ്ട, കുഴപ്പമില്ല. This is the last problem. Okay, so in the next class I will start work energy power. Okay, clear? Trisha, Diya, and I will conduct one small test paper. Is that okay? Can I conduct a small test paper on laws of motion? I will announce the date. Let me check. This question is taken from NCERT. Example 4.10. A cyclist speeding at 18 km per hour on a level road takes a sharp circular turn of radius 3 meter without reducing the speed. The coefficient of static friction between the tire and the road is 0.1. Will the cyclist slip while taking the turn? Trisha, Diya, have you understood the question?
Yes, sir.
Level road means there is no banking. Correct? Understood? Normally the road will be like this. Okay. In some places you might have observed that the outer boundary of the road is lifted a little bit for safety purpose, but here the road is level ground. Okay, it's both left boundary and right boundary of the road lying on the ground. Okay, there is no lifting of the road provided. So theta equal to 0. So you can use that formula. In that formula, please note that there is no banking. Theta equal to 0. Cyclist is there, but I don't want to draw the picture of the cyclist. This is a cycle. Okay, a cyclist taking a sharp turn like this, and okay, this will be the radius of the circular track. It has some radius r, you know that, clear? Cyclist moving along a circle, it will have certain radius, right? That is r. So we have studied that the safe speed, maximum speed, we have studied formula root of rg. This formula you need to memorize. Plus mu s or mu s plus tan theta divided by 1 minus mu s tan theta. Is that formula? Right? Formula. Okay, understood. So in this formula I am putting theta equal to 0. So this tan 0 will be 0. You know that. Lifting is not there. Again tan 0 0. So this entire term cancels. Tan 0 0 the highlighted term cancels. So the maximum safe speed must be limited to root of rg into only mu s by 1, which is mu s is left. Clear? Understood? Okay, all of you clear? Okay, let me substitute the value. I am finding the maximum velocity, safe speed. R is the radius of the circle. Understood? Circular track. So there will be radius. Radius is 3 meter. Correct? 3 meter. And G is acceleration due to gravity, which is approximately 9.8 or 10. Let me take it as 10. Mu s is coefficient of static friction. Coefficient of static friction is 0.1. Correct? Clear?
Yes, sir.
So this multiplication gives root 3. Root 3 approximate value. Do you know the approximate value of root 3? Do you know the approximate value of root 3?
No, sir.
No. Okay, let me write it. In exam, if there is a question, definitely they will use root 3 equal to 1.73. I suggest you better learn it. Okay, you better learn it. Root 3, approximate value of root 3 is 1.73 meter per second is the maximum speed. The cyclist must not go beyond the speed. Clear? Otherwise tire will be skidding away from and it will move away from the track. Clear? Understood? Clear?
Sir.
Sir, in the question they have given us as kilometer per hour.
Yes,
So
yes.
is it okay if the answer is in meter per second?
Yes, definitely we will convert that. Given speed, maximum speed must be this. Let me check the given speed. The given speed is given as 18 km per hour. Let me convert to meter per second because our SI unit is meter and second. So let me convert kilometer per hour to meter per second. Do you know how to convert kilometer per hour to meter per second? Trisha, Diya? Do you know that? Don't know? Then memorize that. If you don't know, please memorize. Kilometer per hour to be multiplied with 5 by 18, you will get meter per second. Understood? Clear? Hello? Okay. So 18 kilometer per hour is much larger compared to Vmax. 18 cancel 5 meter per second, which is greater than the safe speed. The safe speed I got 1.73 meter per second. So the
cyclist.
yes, the cyclist definitely slip. Clear? The cyclist, let me write the conclusion. The cyclist will definitely slip while taking the turn. Why it happens? Because the safe speed, maximum allowable speed is 1.73 for the safe journey, but currently the speed of the cycle is given as 5 meter per second, which is greater than the safe speed 1.73. So the cyclist will slip while taking the turn. Clear? Understood? Okay.
Yes.
So this is very important question. So please memorize that formula: Vmax root of Rg into tan theta plus mu s divided by 1 minus mu s tan theta. Also please note the two cases: no banging but friction is there, no friction but banging is there. The two cases also please note it. So please write down. Trisha, Diya,
Ready.
complete.
Done, sir.
Done. So let me wind up the class now. This chapter is over. Okay, I have explained everything along with the numericals. Nothing is left. So in the next class I will start a new chapter, work energy power. Before that I will conduct a small test paper. Okay, is that okay? Can I wind up the class now?
Okay.
Okay then, bye. Okay, tomorrow, yes, tomorrow there will be class. Test date I will announce tomorrow. Okay, test date I will announce tomorrow. Tomorrow I will start work energy power. Okay, bye.